Time travel feels impossible, absurd, a fantasy for movies and science fiction. And yet, inside the equations of physics, time travel does not disappear. It emerges naturally, quietly, without asking permission. The paradox is not that time travel might be possible. The paradox is that physics allows it and then has no idea how to survive the consequences. We grow up believing time has a direction, past behind us, future ahead, cause first, effect later. This ordering feels so fundamental that questioning it feels meaningless. But physics does question it. Relativity does not treat time as a universal flow. It treats it as a dimension intertwined with space, shaped by motion and gravity. Once time becomes geometry, strange paths become possible. Paths that loop back on themselves, paths where the future touches the past. These are not metaphors, they are legitimate solutions to Einstein's equations. In certain spacetime geometries, time-like curves close. An object following such a curve can return to its own past. No violation of the equations. No contradiction at the mathematical level. Just a universe where causality eats its own tail. This is where discomfort begins. Because causality is not just a physical principle, it is a psychological one. You experience yourself as an effect of the past moving toward a future you influence. Memory depends on it. Responsibility depends on it. Meaning depends on it. Remove causal order and the story collapses. Physics knows this, and yet it cannot simply forbid these solutions. General relativity is clear. If spacetime is curved in the right way, closed time-like curves exist. They are not added by hand, they fall out of the theory. This is not fringe speculation. It is mathematics doing exactly what it is supposed to do. The most famous example comes from rotating spacetimes. If enough mass rotates fast enough, spacetime itself is dragged along. In some solutions, that dragging becomes so extreme that the future bends into the past. Another example involves wormholes. If two regions of spacetime are connected and experience different gravitational or velocity histories, time dilation can turn that connection into a loop. Again, no exotic assumptions, just geometry. This is the equation that breaks causality, and physics does not know how to erase it without breaking the theory itself. Now, here is the crucial point. Physics hates paradoxes, not emotionally, but structurally. A paradox means a theory can generate self-contradictory histories. You go back in time, you change an event, but if you change it, you remove the reason you went back. The classic loop appears: grandfather paradox, bootstrap paradox, information without origin. These are not narrative problems, they are logical ones. A physical theory cannot allow inconsistent histories and still claim to describe reality. So, something has to give. And physics offers several escape routes, none of them comfortable. One possibility is that time travel is allowed, but consistency is enforced. You can go back, but you cannot change anything in a way that creates a contradiction. Every action you take was already part of history. Free will survives only as the feeling of choice, not the power to alter outcomes. The universe becomes self-consistent, but deeply deterministic. Another possibility is that every time travel event splits reality. You do not change your past, you create a new branch, a new history. The original remains untouched. This avoids contradiction, but explodes reality into countless timelines. Causality survives locally, but the universe becomes an ever-branching structure. A third possibility is more radical. Time travel solutions exist mathematically, but something prevents them physically. Some unknown principle intervenes before causality is violated. Stephen Hawking called this the Chronology Protection conjecture. The universe, in this view, somehow protects itself from paradoxes. But here is the problem. No one knows how that protection works. There is no equation enforcing it. No mechanism that clearly shuts down closed time-like curves. It is a hope, not a law. All three options are unsettling. Determinism without freedom, reality splitting endlessly, or hidden rules we do not understand overriding known physics. None of these preserve the comfortable picture of time as a simple sequence. And notice what this reveals. The problem is not time travel. The problem is time itself. The paradox exposes something deeper. Our intuitive model of time is incompatible with the way physics actually describes it. We treat time as a flowing background. Physics treats it as a dimension. Once that shift happens, causality is no longer guaranteed by structure alone. It has to be enforced. And enforcement implies limitation. Something must restrict which geometries are allowed. Something must decide which solutions are real and which are forbidden. That something is not currently in Einstein's theory. This is where the equation truly breaks causality. Not because it allows time travel, but because it cannot explain why causality usually works. We take causal order for granted because our experience depends on it. Memory points one way. Entropy increases, information accumulates. But physics does not derive causality from first principles. It assumes it, or observes it, or builds around it. When extreme conditions remove the scaffolding, the assumption collapses. Consider entropy. The arrow of time is often tied to entropy increasing. But entropy is a statistical property, not a fundamental law. At microscopic scales, the laws of physics are mostly time-symmetric. They do not care which way time flows. The arrow emerges from boundary conditions, from improbability, from large numbers. This means the direction of time is not written into the equations. It is a pattern, not a rule. If patterns can break, so can arrows. And if arrows break, causality loses its foundation. This is why time travel is such a powerful probe. It forces physics to confront the difference between what is fundamental and what is emergent. It reveals that causal order might not be a basic ingredient of reality, but a large-scale behavior that usually holds and sometimes fails. The universe you experience is one where causality is stable, but stability is not the same as necessity. Now, bring this back to perception. Your brain is built on causal sequencing. It predicts, it updates, it assumes effects follow causes. This is not a philosophical choice. It is a survival strategy. If the world violated causality regularly, prediction would be impossible. Experience would fragment. Identity would dissolve. So, your perception enforces causal order, even if the underlying physics does not guarantee it absolutely. If reality allowed rare violations of causality, your interface might never register them. They could be buried beneath layers of consistency-preserving interpretation. Just as you do not feel the Earth moving through space, you might not feel causality wobble beneath experience. This leads to an uncomfortable implication. Causality may not be the skeleton of reality. It may be the skeleton of experience, a rule imposed by the way complex systems like brains must function. Physics then becomes the study of when and why that imposed order holds. Time travel paradoxes show us the edge of that order. They show where the scaffolding runs out. And the fact that physics has not resolved this after decades is not an accident. It is a sign that our current framework treats time as something it is not. Either time is more constrained than relativity allows, or causality is less fundamental than we assume. Both options force a revision of how we understand reality. Notice how quiet this crisis is. There is no announcement, no contradiction you encounter in daily life. Your clock still ticks forward, your memories still align, cause still precedes effect in every practical sense. The paradox lives only at the edges, where geometry becomes extreme and intuition breaks. But those edges matter, because that is where theories reveal what they are built on, and what they are missing. If physics eventually resolves the paradox, it will not do so by banning time travel out of fear. It will do so by uncovering a deeper structure where causality emerges naturally, or where time itself is replaced by something more fundamental. Until then, the equation stands, quietly allowing loops that should not exist, and forcing us to admit that causality is not as secure as it feels. The paradox of time travel is not about going back and changing the past. It is about discovering that the past, present, and future may not be arranged the way your experience insists they are. It is about realizing that the flow of time is not guaranteed by the universe, only by the interface you live inside. And when that interface fails to reflect the deepest structure, paradoxes appear. Physics does not deny this. It lives with it, because denying it would require pretending the equations say something they do not. Time travel remains a possibility not because physicists want it to be real, but because reality refuses to fit neatly into our expectations. And until a deeper theory replaces spacetime itself, causality will remain something we rely on, not something we fully understand. This is Veritas Labs, where truth is tested,